Hello everyone and welcome to this introduction course of the static timing analysis. So basically we are starting the static timing analysis course, and this is going to be focused with the practical aspects. So basically if you are looking for a learning the static timing analysis concept, then basically you can follow this series which I'm going to start. So from where I'm going to start, I will cover the introduction part of the STA, that what is the STA, why we need STA. Then we will cover all the relevant topics that are very important when it comes to STA. So some of the topics we can say that we are going to see what are the timing arc, what is the unit. Then after that, learning this thing, basically these topics are very important. Okay, so we will start with this course, and after that what we are going to see, we are going to see the setup and hold violation, the setup and hold, how we are fixing this, what is the basic concept of setup and hold. I will explain you this concept also. So before that, the basics is required that I'm going to cover. So what it comes to basic, when we say, so in the basic, if we say the timing paths, I'm going to cover what are the different timing paths. In this, all the paths should be covered. Basically we have 4 types of path, but I will cover that multi-cycle path, false path, everything should be covered in this timing paths. Then we will also see how we are calculating the delay. So if we see in the .lib file, we can see that delay characterization is there in the .lib. So we can find out the delay of any circuit, we can find the output transition also. So how basically we are calculating, so these things I'm going to discuss. So everything related with the STA is going to cover in this course. So if I tell you like what is the STA, so here if you see, this S means static. So static means there is no input vectors. So basically we are calculating the timing, like we are calculating the fast path also, we are calculating the worst path also. So min and max, both path we are calculating the timing. So static means we are not applying any kind of input at a input vectors. So in the other case, if we have a DTA, that is dynamic timing analysis, so in that case you see this is a dynamic, that means input vectors is required, input vectors are required. So in the STA we deal with generally with the synchronous design. So like flip-flops we have. So STA determines what is the STA. We are not using any input vectors in the STA. That is the first point. So what is the STA? STA determines if a circuit meets timing constraint without dynamic simulation. So means your design is meeting the timing, your design. So your design is meeting the timing. So then this involves basically 3 steps, like how we are performing this STA. So basically there are 3 steps that we need to understand. Okay, so what is the steps? First is that design is broken. So design is going to broken into timing paths. So design is going to be break in the timing paths. Then what we are doing, the delay of each path is calculated. So you are understanding like how the STA flow is going to be look like. So there will be generally 3 steps for calculating the STA. First is this, like we are going to break a design into the timing paths. The next step is the delay of each path is going to be calculated. And what is the third point? What is the third point? That all path delays are checked against timing constraints. So there will be some constraints. So we need to check the delay of each timing path. So we need to check whether these constraints are going to be met or not, which means if any violations are there, we need to check. And if suppose if there is any violation, then suggest the way to fix those violations. So we need to fix those violations. So you understand what is the STA? Basically, it determines a circuit whether it is meeting the timing constraint without dynamic simulation. So this is all about the STA. So if I tell you that what is the STA, so if you see this, STA is independent of inputs. So that means 0 1 0 1. Okay, so it is independent of inputs. But if we see DTA, it will be depends on inputs. So timing will change in this case. But basically in STA, how we are doing, suppose this is a gate. Okay, we have suppose we have a 2 inputs, so we are calculating for rising edge also, for the falling edge also. So we are calculating this delay. So what is the delay, what is the propagation delay, what are the terminologies that we are using in STA, that I'm going to cover in the later videos. So I will going to follow in the sequence manner. So this is all about the STA and DTA. And just remember, in STA we are considering worst case also and best case also. That means min and max, and rising edge and falling. So this is the basic you should need to understand why we are using the STA only. So basically DTA is timing dependence, and we can't generate that much vector because there will be complex design. So it is not possible, it is not feasible, and basically it will going to take us so much time. So that's why we see our design is synchronous. So most of the design is synchronous. We are using the synchronous design, so STA is going to be preferred. So this is the basic understanding of STA. What is the STA, how we are going to deal with that, and what is the difference between STA and DTA. So from the next video we will start this course. We will see one by one. Okay, so thank you.